The world's a very changing place, and the onus is on us to make sure that we're preserving the planet as we move forward. We want to make sure that we're using our technologies to understand processes on the planet that are rapidly changing.
HyspIRI is a proposed Earth orbiting mission which will look at different Earth ecosystems, including reefs and volcanoes. The first part is you build an instrument, you get it tested in the lab, make sure it all works, then you put it in an airplane, ultimately to prove out that this concept is worthy of being on a satellite mission.
If we can get as close to space as possible, that's the best way to simulate a satellite and its data.
We have the AVIRIS instrument, the Airborne Visible Infrared Imaging Spectrometer, and we also have the MASTER, which is the MODIS ASTER simulator. The AVIRIS instrument is measuring the solar reflected spectrum, so the light that's coming down from the sun, hitting the surface of the earth or the surface of the water, and then bouncing back up. And then the MASTER instrument's actually measuring emitted heat or thermal infrared data. The two data sets together simulate the HyspIRI satellite payload.
What we're doing in Hawaii is studying the volcanoes and the coral reefs around the islands.
They say that all kids are interested in volcanoes and dinosaurs, so I guess in some respects I never really grew up. But what appeals to me about them now is it's one phenomenon that has an almost immediate impact on the people living nearby the volcanoes. It has an impact on the environment, both on a regional and global scale. The lessons we learn here with our aircraft mission, with our processing of the data, with our ground measurements will all be used to develop techniques so we'll be ready for the launch of the HyspIRI mission. And as soon as data hits the ground, we can then put it into the models and improve forecasts from day one, essentially.
Coral reefs are important ecosystems. In terms of biodiversity, they represent the most biodiverse ecosystem within the ocean. By comparison, they are very similar to what we know about rainforests on land. In fact, many people refer to them as rainforests of the sea. We need to know how these important ecosystems respond to climate and population now, before it becomes too late. The ER2. It's able to fly at 65,000 feet. That's above 99% of the Earth's atmosphere. It can easily collect data that we think would be useful and built into a future satellite sensor.
This morning, we're ready for takeoff at about 8:45. The plan is to fly over the big island of the volcanoes, and then on the way back, fly a coral reef line over Molokai. There's people in the field at the volcanoes and coral reefs, so they'll be taking measurements on the ground to correlate the data obtained from the ER2 airplane.
Typical morning will start out prepping the aircraft, installing panels, setting fuel counters, installing the experimenter's instruments.
We check out the autopilot, the radios, some of the warning systems in the airplane, navigation systems, and then we get it ready for the mobile pilot to show up.
The ER2 is a very unique aircraft. We can get a very wide swath with these super high-tech instruments, a lot of which are going to end up on satellites. So we're kind of the last step in development on some of our Earth science satellites, where we actually take it up to extreme altitudes and cold soak it and put it in an extreme environment. Because once we launch them into space, there's no repairing. It might be kind of strange seeing another pilot set up the airplane for the pilot to actually fly them, but we fly so high that there are a lot of special considerations we have for flying. The hardest thing is we have to wear a spacesuit when you fly a full pressure suit. So Dean's in there starting to get dressed in his pressure suit right now. Once he's in that suit, he can't do a whole lot of moving because it gets too warm and the heat builds up. So yeah, his technician's getting him dressed. They'll drive him out here, they'll walk him up to the airplane, and he'll hop in This will all be set up basically for engine start and takeoff.
When he taxis out, we follow right behind him, and he'll taxi onto the runway where he will prepare to launch. Then we get out of the aircraft, remove pogo locks, do final checks on the aircraft, remove our emergency start system pin, safety gear, clear the aircraft, and then as soon as he takes off, we'll follow behind in the truck to recover our pogos. I've been working aircraft a long time. This aircraft is different in a lot of respects. It's something unique. It's always a challenge. It's always exciting. It's a lot of fun.